VLSos here. This is a video lesson on operations with functions. I'm going to define a function and call it f. F of x is equal to 1/2 x plus 6. We're going to review some basics. What we've called the f function, we can think of it as doing mathematical operations. And operations are actions that we take on numbers. Add, subtract, multiply, divide, power of root. Specifically now, the f function takes x and it multiplies by 1/2. And then we add 6. Which reminds us that the actions that we take have to be done in a particular order. And the order of those operations, we can remind ourselves what that order is by the mnemonic GEMDAS. In GEMDAS, A and S stand for addition and subtraction. Two operations which are inverses of each other. Addition is not really done before subtraction. Addition and subtraction are done at the same time as you read them in the equation from left to right. Likewise, M and D for multiplication and division are inverses of each other. They're done at the same time as you'd read them from left to right. And E, even though it's a single letter on its own, also stands for an operation that has its inverse. E is for exponents. And what we mean by an exponent is a power like x to the n, and its inverse is rooting, or the nth root of x. And we power and root at the same time as we read them from left to right. G is not technically an operation, but it's a necessary part of the order of operation. G stands for grouping symbols. There are many varieties of grouping symbols, like various parentheses. The division bar is also a grouping symbol, and it's important in the order of operations because we use grouping symbols to force certain math to be done in an equation for others, if that's our need or intention. So if f is doing math operations to x, then we also have a process which will undo what f is doing. We call that the inverse of f. The process can be reversed. To what we say undo. If the process is multiply by 1/2 and then add 6, the reverse of that process first starts with the inverse of addition, which is subtraction, and then the inverse of multiplying by 1/2, which is dividing by 1/2. Which is the same thing as multiplying by 2. Symbolically, that means that if the f function takes x, we can undo the f function literally by subtracting 6 and then dividing by 2. And what we would get if we did a process to x and then undid it would then be x. We have a symbol for inverse. The inverse of a function named f is then the name of that function with a -1 superscripted. We call this inverse of f, or f to the -1. So symbolically, if we have an f function and we put all of that f function into the inverse of that function, or in this case, I've created what's called a composite function, the inverse of f composed with f, then the inverse will undo f, leaving x. This is an example of two functions working together. We can provide more examples of functions working together. I can define a function g of x, in this case, is equal to 3x minus 1, and another function h, 2x plus 7. And I can think of performing operations on these functions. I can multiply g and h, I can divide g and h, I can subtract, I can compose one with the other. The sum of g and h can be found as its own function by taking the expression for g and adding the expression for h. And if I combined like terms and simplify, I would have the expression for the composition g plus h, in this case 5x plus 6. I could define a function based on another. In this case, the new function j will be defined as the g function plus 2. And I can find the expression for j by taking the expression for g and adding 2. If I simplified, in this case it would be 3x plus 1. And I could say that in this case, because j was defined as a transformation of g, I've transformed g by adding 2 to all of its values. If I saw the graph of g, it would look like the graph would rise up by 2. I'd say j is a transformation of g. This is just a beginning on how we can use functions and function notation to perform many mathematical operations and transformations.